So because we have just now defined a mathematical expression, we can define modulation index mu a, which we also write in the form of small m. In case of double sideband full carrier, it is Vm by Vc, and it is always less than 1 if you remember. On FM side, the modulation index mu f is nothing but delta f upon fm, when delta f is the frequency deviation and fm is the modulating signal, and mu f in case of wideband fm will be greater than 1. So here modulation index is less than 1, and here often modulation index will be greater than 1. So you can define modulation index on both the side, and you can also write a lot of things about them, because you can see here modulation index does not depend upon modulating frequency, but here it depends upon FM, which is modulating frequency. So you can also mention those points in this point number 4. Next point number 5 can be about bandwidth. Bandwidth in case of double sideband full carrier is nothing but twice FM. No doubt, if I'm using single sideband transmission, then bandwidth will be only FM. But as I mentioned earlier, when we talk about AM, we talk about conventional AM, which is double sideband full carrier. On the FM side, bandwidth is always given by Carson's rule. So bandwidth on the FM side will be nothing but the Carson's rules, and Carson's rule says that it's twice delta F plus FM, and this can further be written as twice mu f plus 1 into fm. Both are the valid expression. This is nothing but the Carson's rule. So you can see bandwidth depends upon modulation index here, because it further depends upon frequency deviation. Here bandwidth only depends upon modulating signal frequency, which is fm. Let us move on to the next point number 6. We can talk about signal to noise ratio, SNR. SNR is poor or less in case of amplitude modulation. Here SNR is high. SNR can be improved. Now why SNR is high? That is because of various reasons. For example, amplitude limiting is possible in FM. Now what is amplitude limiting? In case of FM, because my signal will be of constant amplitude, if there is any amplitude change, that has to be due to noise, and hence I can use a clipper circuit and remove the excess of amplitude. So I can remove the effect of noise basically. We cannot make out whether that amplitude change is due to noise or it is the original amplitude change, which is due to the putting the information in the amplitude of the carrier. So we cannot truncate any amplitude, we cannot use amplitude limiting in AM, and hence the effect of noise is more in case of AM. In other words, SNR is less. One more reason why SNR is high in case of FM is due to the use of pre and de emphasis. So we use pre and de emphasis, which will further help us to improve the SNR in case of FM. Now no such concept is available for AM. So in summary, we can say that SNR is large for FM compared to AM. Next point will be about frequency range for radio communication. Both AM and FM are used in radio communication. The range of frequency here is that is the station frequency or the carrier frequency. We have already discussed this before. It's 540 kilohertz to 1650 kilohertz. In the application of radio communication, the station frequencies vary from 88 megahertz to 108 megahertz. So that's the range. Various FM stations are available in the range of 88 megahertz to 108 megahertz. There can be one point of differentiation in terms of the nature of antenna which is used in the receiver side. In case of AM, we normally use ferrite rod antenna for receiver, whereas in case of FM, we normally use dipole antenna on the receiver side. So that's one point of differentiation. Let us continue with few more points of comparison. We are comparing FM and AM.